Okay, so it looks like it has finally arrived. And, let's see, is that in focus? I think it's hard to tell. Let's see what we got inside of here. Okay, I guess that's it for a package. Let's see, what is this? Excel. Okay. Okay, so styrofoam, and let's just cut this guy open and see what we got here. Oh yes, my neon lights. Look at that. 100 neon lights. We have some interesting experiments to do with these. Okay. Should be fun. Let's check that out. Okay, so here I have my plasma amplifier I'm working with. This is about 1 kilo ohm resistor, and I probably shouldn't be using an inductive one, but I am. And I'm using one neon light to as a preamplifier, and then the second one hooked in series as to increase the amplification. And we're about 20 kilohertz right now, and we are getting a signal here that is on the 2 millivolt scale, and so it's about 20. I'm using a piercing coil to measure that. It's about 0.1 volt per amp. So it's about 10 times the amount of amps, so about a modulation of 20 milliamps. And when I change the amplitude, you can see the amplitude goes up and down. And when I change the frequency, definitely the frequency goes down. And when I bring it up, okay, so we're about right here. I guess that's kind of getting toward the limit of what we can do. That's about 100 kilohertz, maybe limited by our transformer here. Let's bring the frequency down. And we're definitely getting triggering on. Okay. I'm putting the square wave into it, and I'm getting a square wave out of it. Very cool, huh? My plasma amplifier. Although it's not getting as much modulation as what I was hoping. I might need a higher voltage still. Okay, let's try going down to a lower frequency range. Okay, well, I'm getting higher amplitude. It's almost like pulse modulation. Again, we have our 2 neon transformers, or neon lights here, and our transformer. Okay. And it's definitely frequency controllable. So maybe it's because there's no, well, there is a resistor in there though. So I can definitely control the pulse rate of that. Up. This is about 1 kilohertz right there, and this is 11, 12 kilohertz. Okay, up there. I'm definitely able to. Let me change up the sine wave and see what we get. Okay. That's sine wave input. And looks like we're getting more of a sine wave type output. So with the square wave, We are getting some kind of amplification because this is on sine wave now. We'll put it back on the square wave. Get higher peaks due to the transients. Very cool, huh? Okay, just wanted to make sure things make sense. So this is about 5.68 kilohertz as measured on the scope. And we're putting in a signal of 5.8 kilohertz up here. Okay. I have a feeling maybe if I modulate it with a higher voltage input that it will get better modulation on the output. We'll have to see. Okay, so I'll quickly just run it at these lower frequencies with a single neon light. And it's running kind of bright there. And I think we might get a higher signal and get some reverse there, but I think if we run it with 2, we get a better overall signal. And it shares the power between the 2 neon lights. See, it looks more of a switching type of signal when we run it with 2. Very interesting, huh? Of course, 3, I tried 3, it doesn't really want to, it's got too much resistance. It needs a higher voltage for 3, really. Because, it's not really lighting the third one up very much. Okay. Very interesting, huh? So as I said in my last video, plasma can be used as an amplifier. And of course, if you have a neon light here, let's get one out. Okay, so we can use a neon light as an amplifier. Okay, and the IV curve is actually negative over a certain part of the range. So here's the circuit that I'm looking at, and I have this high voltage battery, 130 volts, made out of 18650 batteries, and it runs through 2 neon lights and then a 1K resistor. And one of the neon lights, I put some capacitors to isolate it, and maybe it's not necessary because well, I guess it is necessary because you got a DC block this from going to the transformer. I have a transformer to isolate our signal generator source. It steps up the voltage, and so I modulate the signal here, and then it further modulates it with a second neon light. The second neon light acts as like a second stage amplifier, and so I can amplify RF signals. Well, maybe not quite RF because the transformer has a bandwidth that's limited, but if I used a higher frequency transformer, then I probably could extend the range up to this amplification to even higher frequencies. And looking at this as a possible different type of amplifier rather than transistors or vacuum tubes, a plasma amplifier. Very cool, huh? There we go. There we go, plasma amplifier.